This chapter is all about a concept that will be new to you, which is quadratic functions. This video in particular is just meant to go over some basic definitions of concepts that you're going to need to know as we go through the unit. Take notes as you go, but be aware that there is a file up on the website that has notes that you can download and fill out while you go through the video. Also remember to pause if necessary so that you can copy things down. Our first definition is one that you'll hopefully remember from grade 9 and grade 10, which is polynomial. This is one or more terms which are separated by addition or subtraction that have variables with whole number exponents. That last bit is the important part. So we've got some examples here. We see x, 3x plus 1, x squared plus 2, and 8x cubed minus 2x plus 1. Note again that the terms are all separated by either addition or subtraction, and that all of our exponents are whole numbers. Next up is the most important definition of the entire video, which is quadratic functions. Quadratic function is any function that involves a polynomial that has a degree of 2. If you think back to degree when you learned it last year in grade 10, that talks about the size of the exponents of your variables. So degree of 2 means we have an x squared, or some other variable squared. When we graph quadratic functions, which we're going to do a lot of in this course, we always get roughly the same shape. So you see here we've got 3 different graphs of different quadratic functions, and they've all got this arc. This shape is called a parabola. The specifics of the graph may change, but the overall shape is going to stay the same. We'll get more into the details of how to draw parabolas in a different lesson, but for now I just want to highlight a few things that I don't want to see when you're drawing parabolas. First things first, parabolas do not have a point at the bottom. They're a smooth curve all the way through. They also don't randomly start to curve back in either direction. They're always going up or down. And worst of all, they don't make a V shape. There's no straight lines anywhere in a parabola. These are all mistakes that make Mr. Ham very annoyed, so don't do them. Now that you know what parabolas are, the rest of this video is mostly going to focus on some of the characteristics of parabolas that you'll be able to identify from graphs and functions. First up is the direction of opening. This one's pretty basic. It's just whether the parabola is opening upwards or downwards. So you can see from our 2 graphs here, one is opening up and the other one is opening down. Next we have the vertex. This is the point in the middle of the parabola where the graph flattens out and switches from going downwards to upwards or vice versa. And it's always going to be either the lowest or the highest point on your graph. So again, you can see here from our 2 examples, we've got one where it's at the bottom and one where it's at the top. We see vertex a lot when we're dealing with word problems, when we want to find the highest or the lowest value of something, so keep it in mind. Next up is another fairly self-explanatory one, which is the maximum and minimum values. These are just the largest and smallest vertical values of the graph. One of them will be at the vertex, and the other one will generally be positive or negative infinity. Please keep in mind, this is just the vertical values. We don't care about horizontal positioning at all. So if we look at this example graph here, our minimum is going to be at the vertex, and our maximum is going to be at infinity because the graph just keeps going upwards. If the graph were flipped, our maximum would be at the vertex, and our minimum would be at negative infinity. Moving on, we have the axis of symmetry. This is just an invisible line that splits our parabola into 2 mirrored halves. It always goes through the vertex, and it always has the equation x equals something, where that something is the x-coordinate of the vertex. Next up is the x-intercept. This is the value or values where the parabola touches or passes through the x-axis. You'll sometimes hear it referred to also as the roots or the zeros of a function. And depending on how the graph is drawn, there might be 0, there might be 1, or there might be 2. So if we look at these 3 graphs here, we can see the graph on the left never touches the x-axis, so it has 0 intercepts. The graph in the middle just skims the axis, so it has 1 intercept. And then the graph on the right passes through it in 2 places, so it has 2 intercepts. To go along with the x-intercept, we also have y-intercepts. And these are the values at which the parabola passes through the y-axis. And generally, there's almost always going to be 1. So if we look at our graph here, we can see our graph passes through the y-axis in one place. It's never going to loop back around. It's never going to cross it anywhere else. Y-intercepts aren't going to be as important as they were last year when you were doing linear equations, but they'll still pop up from time to time. And our last two definitions are two concepts that you will have learned last year, which are domain and range. So domain is the set of all the possible x values for a function. Range is the set of all possible y values for a function. So what these really are is just describing the extremes, how far a function goes to the left, to the right, up, and down. Once you get into grade 12, you'll start to deal with more complicated stuff, but for us, this definition will do. Now that you have all of your definitions, it's time to put them together and do a couple of practice questions. So we're going to look at a couple of graphs, and for each graph, we're going to see if we can figure out 9 things: the direction of opening, the location of the vertex, the maximum and minimum values, the axis of symmetry, the x-intercepts, the y-intercept, the domain, and the range. So looking at our first graph, we'll start with the direction of opening. This one's generally pretty clear. We can see that the graph is opening upwards. For the vertex, we look down at the bottom of the graph, and we get the x and the y coordinates, and we can see that our vertex is at -4, -9. For the maximum value, if we look up at the top of the graph, we can see that the graph actually just goes to the edge. This is meant to tell us that the graph just keeps going on forever. So it's going to go up forever and ever and ever, and so our maximum value is going to be infinity. Our minimum value is our vertex, which is at the y value -9. Our axis of symmetry goes right through the middle of the graph, and that's going to be x equals -4, which is the location of our vertex. Our x-intercepts, if we zoom in a bit, are at -1 and -7, and our y-intercept is at 7. Our domain, again, if we look at our extreme values, we can see that the graph goes left and right forever because those two lines at the top are just going to keep going. That means our domain is actually just going to be everything, or all real numbers. Our range, if we look at the bottom, we're never going to get below -9. So we know our y values are always going to be bigger than that. If we look at the top, the graph just keeps going up. So there's not much for us to describe there. So what we would say for this graph is that the range is that y must be greater than or equal to -9. All right, let's try another one. So we can see here we have another graph, and we're going to want to do the same 9 criteria based just on this new graph instead. I am going to ask you to try to do this one by yourselves, but before you do, one thing to note. If you look at how this graph is drawn, you can see that the line actually stops at our axes. So it doesn't go left past the y-axis, and it doesn't go down past the x-axis. So that is going to affect several of your criteria. So think hard before you put your answers down. Pause now, try for yourself, and then come back and watch through the answers once you're done. Welcome back. Let's go through our 9 answers. So looking at the graph, we can see that the direction of opening is down. Our vertex is at 10, 20. Our maximum value is at our vertex because the graph opens down, and it is 20. Our minimum value in this case isn't going to be -infinity because the graph stops. So our minimum value is actually going to be 0 because that's the lowest y value the graph reaches. Our axis of symmetry goes through the vertex. It's going to be x equals 10. We only have one x-intercept here. It's at 30. And our y-intercept is at 15. Our domain and our range are a little different here, again because the graph stops at the axes. So for our domain, our lowest x value is 0. That's the farthest left we get. And our highest x value is 15. That's the biggest we get. So x is always going to be between those two numbers. So what we'd say is that x has to be between 0 and 15, or 0 is less than or equal to x, which is less than or equal to 15. Our range is going to follow a pretty similar pattern. our lowest y value is 0, our highest is 20, and so we're always between those two numbers. So we'd say that 0 is less than or equal to y, which is less than or equal to 20. Now that you made it through to the end, make sure you do the practice problems for this lesson. There will just be a couple of those to help make sure you're understanding things. And then once that's done, make sure you also try out the textbook questions. If you run into trouble, feel free to let me know or ask in the help forum so that one of your classmates can also give you a hand. If you don't need help, maybe check in the forum just to see if somebody else could use some help from you. Otherwise, good luck with the rest of the material for this unit.